The gravitational potential of a body is the potential due to the Earth's gravitational field of the Earth. Okay, and it is the work done in taking a unit mass of a body from infinity to a particular point, and it has a mathematical expression given as V is equal to gm over r minus gm over r, and it has a unit of joule per kilogram. Now you will realize that I added a negative sign here. What then is the implication of the negative sign? The negative sign indicates that the potential decreases as the object is moved from infinity towards the Earth. This is a likely exam question. What is the implication of the negative sign that is attached to the gravitational potential? And I said that it simply indicates that the potential decreases as the object is moved from infinity towards the Earth. And we have that V is equal to the gravitational potential. G is equal to the gravitational constant. And I said it has a numerical value of 6.67 times 10 raised to the power minus 11 Newton meter squared kilogram raised to the power minus 2. All right. And of course, M is the mass of the Earth. M is the mass of the Earth, and R is the radius of the Earth. R is the radius of the Earth. We can relate the gravitational potential of the body to its gravitational force. How can we do that? Okay, let us recall that F is equal to gm1 m2 all over r squared from our first class. Okay, we said that the force of attraction between the two masses or two bodies is equal to the product of the gravitational potential, the gravitational constant, and the two masses all over the square of the distance between them. Okay, since we have that F is equal to gm1 m2 over r squared, we can make the G the subject of the formula. And how can we do that? We have gm1 m2 equals fr squared. If I divide through by m1 m2 and I divide through by m1 m2, we'll realize that this will cancel out, and I am left with G is equal to fr squared all over m1 m2. Is that okay? This is what we have. All right, but you will recall that V, so recall that V is equal to minus gm over r. V equals minus gm over r. Since we have G to be equal to this, we can substitute it into the equation we have over here, and we would see that V will now be equal to minus fr squared m over m1 m2, okay, because G is equal to this. All right, so we would have times r. Okay, let me do this well. So we have that V is equal to G is fr squared over m1 m2, okay, times m all over r. So this can cancel out, and I am left with fr squared over m1 over r. So V is equal to fr squared over m1 divided by r over 1. So this gives us fr squared, okay, over m times 1 over r. This cancels out, so V will be equal to fr over m, Fr over m. But remember that we have a negative sign over here. So the negative will affect the gravitational potential also. So we have minus, 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 and minus. So the relationship between the gravitational potential and the force of attraction between the two masses is equal to this relation over here. So depending on what you are given in the particular question, you can maneuver your way around the formula you have to get your required solution. So let us consider an example. We are told that we should calculate the gravitational potential at a point on the Earth's surface if G is equal to 6.6 times 10 raised to the power minus 11 Newton meters per kilogram squared, and the radius and the mass of the Earth are 6.4 times 10 to the power 6 meters and 5.98 times 10 to the power 24 kilogram respectively. So how do we go about this? Of course, the first thing is to state your given parameters. You have G to be equal to 6.6 times 10 to the power minus 11 Newton meters squared kg minus 2. We have R to be equal to 6.4 times 10 to the power 6 meters. We have M to be equal to 5.98 times 10 raised to the power minus times 10 raised to the power 24 kilogram. All right, and we are asked to find our gravitational potential, but we know that gravitational potential V is equal to minus Gm over R. So we can substitute the parameters we have and solve for our gravitational potential. So we have this to be equal to minus 6.6 times 10 to the power minus 11 times 5.98 times 10 to the power 24 all over 6.4 times 10 raised to the power 6. So this simplifies to 6.6 times 5.98 all over 6.4 times 10 raised to the power minus 11 plus 24 minus 6. And if you simplify this by computing it, you realize that your gravitational potential is equal to minus 6.2 times 10 raised to the power 7 joule per kilogram. Okay, joule per kilogram. So this is our final answer. So this is the end of the class on the gravitational potential. I'm sure you have a better understanding of what we just discussed. But in case you have questions, you can ask your questions on the platform, as we would always be here to attend to all your worries. So see you in our next class, where we will consider the acceleration due to gravity, or the gravitational field intensity. I am sure you would not like to miss the next class. So see you in our next class.